Hi everyone! Today, we're diving deep into a fascinating and powerful aspect of Linux. We will explore how to read directly from a running program's memory. Specifically, we are talking about /proc/$PID/mem. This file gives you a raw look into a process's virtual memory space. It is a tool for advanced debugging, security analysis, or just understanding how Linux works internally. Reading from /proc/$PID/mem is not something you do every day. It is powerful but also complex. First, what exactly is /proc/$PID/mem? It is a special file. It represents the entire virtual memory of the process with ID $PID. Every byte in that file corresponds to a byte in the process's memory. But there is a catch. This is virtual memory, not physical memory. The operating system maps these virtual addresses to physical RAM. You need proper permissions to read it. Usually, you need to be root. Or you need to be the same user as the target process. Sometimes, you might need specific Linux capabilities like cap_sys_trace. Without these, your access will be denied. So, how do we actually read from it? It is not as simple as just cat-ting the file. That would be a huge binary mess. We need a more structured approach. Let's break it down into a few steps. 1. Identify the process ID, PID. You need to know which process you want to inspect. Use tools like PSAUX or pgrep to find the PID. For example, find the PID of a simple C program you wrote. 2. Understand the memory map. This is crucial. A process's virtual memory is not one continuous block. It has different regions. These regions are for code, data, stack, heap, and shared libraries. These regions are described in /proc/$PID/maps. This file lists address ranges. It shows permissions like read, write, execute. It also shows what those regions are for. For instance, it might show an address range like 0x7f123400000x7f123401000 as your program's code section. You need these addresses. They tell you where to read in /proc/$PID/mem. 3. Open /proc/$PID/mem. You open this file just like any other file. Use C, Python, or your preferred language. Open it in binary read mode. 4. Seek to the desired address. This is the key. The virtual addresses from /proc/$PID/maps directly map to offsets within the /proc/$PID/mem file. If you want to read from virtual address 0x7f123400000, you seek to that exact byte offset. 5. Read the bytes. After seeking, you read a specific number of bytes. You need to know how much data you expect. For example, for an integer, read 4 bytes. For a string, read until a null terminator. The data you read will be raw binary. 6. Interpret the data. This is where your knowledge of the target program helps. You need to know the data types. Is it an integer? A string? A pointer? Convert the raw bytes into a meaningful format. This entire process requires careful handling of addresses and data types. It is not for beginners. Be precise with your offsets and lengths. Reading past a mapped region might cause errors. Always double-check /proc/$PID/maps for valid address ranges. For example, to find a string in a program's data segment, parse /proc/$PID/maps. Find the data segment's address range. Then, seek to its start in /proc/$PID/mem. Read chunks of data. Search for your string pattern. This is how many memory inspection tools work. It is a low-level operation. It offers incredible control. But it demands great care. That is a quick but detailed look into reading from /proc/$PID/mem. It is a powerful technique for understanding process internals. Thank you so much for watching this video. I hope you found it informative and exciting. If you did, please hit that like button. Also, do not forget to subscribe for more deep dives into Linux and programming topics. Your support helps this channel grow. See you next time.